We're going to estimate large numbers, and we're going to do this using a really cool fact of math, which I'm not going to take time to prove now, but we'll talk about later. It turns out that a positive number, k, has n plus 1 digits if and only if log k is in the interval n to n plus 1. So in other words, if I take the common log of some big number k, it'll have as many decimal places as the log of that number. So we're going to look at the number k. Suppose k equals 234 to the 567th power. And notice there's a huge issue here. Our calculator, if we try to use this, is just going to have all sorts of problems. 234 raised to the 567th power just becomes this really enormously big number. So we're going to just not even look at that for now. And let's just see if we can calculate what it is or get close to what it is using another method rather than trying to do that out by hand or anything else. Well, we know that it's going to have as many digits as the log of both sides. So the log k is equal to 567 log of 234. We just move that power over to the front. Well, to figure out what this is, we get out our calculator and we do 567 times 234 log equals, and that's 1343. That's approximately equal to 1343.345. Let's go a couple more decimal places. 3911. 12. There. So now that we know this, we know that k is approximately equal to 10 to the 1343.3453912, which we can break this apart. It's approximately equal to the 3.43 times 10 to the 0.3453912. We're going to use that property of exponents backwards. We're going to separate into the integer part and the non-integer part. Well, we get out our calculator again, and if we take 10 raised to the 0.3453912, that's going to give us 2.21, 508.9 times 10 to the 1343. So let's remember this number for a second, because we just saw this. Remember that we did 234 raised to the 567, and notice what we got, 2.215089 times 10 to the 1343. So we can use this as a way of approximating or estimating large numbers. Look how close we were using our estimation with taking the log of the number. So that's one way of estimating very large numbers.